So in this part of this tutorial, I want to introduce you to something called data types in Python. Okay. Now, data types are really important, not just as a data analyst or in Python, but in every form of programming you will do and across different types of programming languages that you will be using. Understanding the type of data that you are using or the type of data that are available to you will allow you to work efficiently and more accurately without encountering some kinds of error. So, but before we go ahead to show you or to learn the different types of data we have in Python, let me give you an example of why data types are really important. So let's say we have first number here. Of course, this is a variable and we give it a value of 100. Okay, so in this variable location or in this system location called first number, we are giving a value of 100 to that. Okay, so in the second position we say second number, and we also give it a value of 100. Okay, now there are two different things that is happening here. The first 100 right here is without a quotation mark, while the second one is has a quotation mark. So let's sum the both of them and see what we'll get. So sum equals to first number plus second number. Okay, so let's run this now. And now we encounter an error. The error says unsupported operand type for addition, int and string. Now what this error is simply trying to say is that we are trying to add two numbers together that are not related in any way. Okay, so we are trying to add a number here. This is what we call an integer or an int in Python. Okay, so the value of this first number is an int, while the value of this second number is a string, something called a string. So even though it looks like a number, it is inside the quotation mark. And in Python, whenever a number or anything at all, whether it's a string, a number, or any value at all, whenever it is inside the quotation mark, it becomes a string. It becomes like a word. And you cannot add a word to a figure. That is like the simplest explanation. You can't add a set of letters to a figure, okay, even if they sound the same way. So we have this as 100, but it is without a quotation mark, and we have this as 100 inside the quotation mark, which automatically becomes a string. So the only way we can perform this or this addition is if we are working with two numbers that are either a float, which we are going to look together, or an int. So what we can do here is to remove this quotation mark within that 100 there, and then we'll run it again. Now when we run this particular calculation, it should run successfully, and if we print 100 right now, I mean sum right now, we should get our solution as 200. So that is the reason why we need to understand the types of data we are working on or we are working with, so that we can perform the operation that we work on those particular data that we are working with. Okay, so since like we mentioned in our previous video that variables are used to store values in specific location in the system so that we can use it. So imagine you have this large system and then you don't know the value or the types of data that are stored in a specific place. Then you just start working with them. You are bound to like start making errors, okay, until you discover the types of data that those variables are storing. That is the importance of understanding data types in Python. And in this tutorial, we are going to go over some of the basics and some advanced types of data that we will encounter in our day-to-day usage of information or data in programming. Now, the first one we are going to look at is something called an int, and I've added some example here. An integer is an int or an integer is a whole number that does not have a decimal place. Okay, so you have something like 400, 200, 50, minus 30, minus 40. So an integer can either be negative or positive, but provided it doesn't have any quotation mark around it or it doesn't have a decimal place, a decimal position, then that number is called an int or an integer in other programming languages. Okay, so that is very basic example that we've shown in this place. So for example, this particular number here is assigned to 100, which is an whole number, and it becomes an integer. Thankfully, in Python, we can easily verify if what I'm saying is true. Okay, so there is something called a function, which we are going to talk about how to declare functions and methods subsequently in subsequent tutorials. But there's a function that Python offers us that allows us to check the type of variables that we are working with, to verify the types of variables that we are working with, and this will come in very handy. And it has a very simple name called type with a small letter T, and then you open these two brackets and close this bracket and then close it. So whatever variables you enter here, it is going to return the types of variable back for you so that you understand what you're working with. So because we declared some variables up here, I'm simply going to copy one of these variables, either first or second number. um I'm going to copy it and paste inside this type here. So I'm going to paste it inside this type, and then I will run it. Now it returns back an int, so simply telling us that second number, which we've worked with previously, is a type of an integer, or the data type that that particular variable is storing is an integer, right? So again, an integer is a whole number that doesn't have a decimal place, whether it is negative or positive whole number. Provided it doesn't have a decimal place, then we call that an int. Now other simple or other common types of number you come across is something called a float, and it's almost like the opposite of an integer. Whenever a number has a decimal place, then it becomes a float automatically. So let's go down here and declare another variable. So we can declare this variable and say mean. So let's call a mean of a set of number, and we'll give this 20.3. Okay, like I mentioned previously, it has a decimal place, so automatically it should be called a float. Okay, so if I run this right now and then use type again, the function I just showed you above, and then put in mean inside of it. I'm simply saying what is the type of mean right now. So if I run this right now, it's going to tell me that it is a float. The reason is because it has a decimal place. Now let me prove it to you again. I'm going to remove this decimal place and save it again. If I run this right now, I should have an integer because I've removed that particular decimal place. So they are all numbers. Both ints and floats are talking about numbers, but one of them, which is a float, has a decimal place, while the other one does not have a decimal place. So let's also test it when we have a negative number behind this. So if we save means as -20 and then we'll run this again, we can still see that it's an int. Okay, but let's add a decimal place to this -20 now. So -20.2, and then we'll run it again. You can see that it becomes a float. So any number, whether positive or negative, that has a decimal place is a float. Any number, whether positive or negative, that does not have a negative number is called an int. That does not have a decimal place is called an int, right? Now the next type of data we are going to look for, or we are going to study, is something called a string. Okay, now we showed a few examples why we are introducing this video. A string, which Pythons represent by str, is any number or anything, whether it's a number, a text, a group of text, letters, or anything at all that is enclosed in quotation mark, whether the quotation mark is single or double quotation mark like this. So whether it's a single quotation mark like this, say house, that is what we call a string. So just know a string like um a sentence, a words or letter, but provided those are enclosed in quotation mark, it automatically becomes a string. Okay, for example, let's call this age. So we can call this age and we can say 27. Okay, now looking at this age now, it's supposed to be a number, but maybe someone who was writing or storing this particular variable added it in a quotation mark, you might assume that it is an integer or is a float, and you might start to, like, try to perform calculation on it. It's not going to work. It's going to throw you an error. So when we run this right now, age, even though it sounds like a number, call it 27, it's actually a string, a type of data called a string. So if we do this type, if we do type it once again, and we put age inside there, and we close it, and we run this, it should tell us that this is a string. So this is type of data that is a string. So this should let you know that you should not perform things like arithmetic operation or mathematical operation on this particular number, because it's actually a string. Okay, right. So those are like the three common data that you will use. Okay, now the last one is something called a Boolean, and this is something you will widely see across programming language, across your data analysis journey. Something called a Boolean. Now a Boolean is a true or false value. It's usually used when you want to compare if something is equal to another thing, or if a state of thing is actually true or false. For example, you are building a software and you want to see if that particular date is maybe Wednesday or Tuesday. So you use a Boolean to like test that particular logic. For example, you can say is today Sunday, and because today is Sunday in my system, I can simply set this to true. So the true is with a capital letter in Python, so I set it to true. So if I run this particular one now, and then I say type is today, or let me just copy this and paste. Just copy this and paste here. Is today Sunday. So if I run this right now, it's going to tell me that that is a type of bool, because we are trying to test a particular logic and see if it is true or not. Okay, now let me show you a very practical usage of let me show you a very particular usage of Boolean. Okay, now let's look at this. Let's look at this. We have age here. We have age here above here that we declared that was 27. So age here was 27 in string. So let's say age 2, and we set this to and we set this to 27. Okay, so this one is in quotation mark and this one is not in quotation mark. So if I run this right now, what I want to do is answer. So I'm going to create a variable called answer, and I'm going to equate it to age equals age 2. Now what I'm trying to do here is that I'm trying to see, whenever I see someone use two equal sign in Python, what the person is trying to do right there is trying to compare if one or two variables is equal to that part, the next variables. Okay, so in this sense, what I'm actually trying to do here is trying to compare if age is equals to age 2. So this two equal sign is called a comparable or a comparison sign in Python programming. So whenever you use those two signs, you're trying to compare if something on the left is equals to something on the right. Okay, now I'm equating the results to answer. So let us see what the answer will be. So if I run this right now and I print out answer, run this. So you can see the answer is false. The reason why it is false is because even though this is 27 and this is 27, they are of different data types. Okay, this particular guy is string, and while this particular guy is an integer, so they are not the same. All right, but if I come here right now and change this particular guy to 27 and then I save it, and then I come right here and run this particular one now, and then run the value of our answer, you can see they now become true. So the value of age here is also equals to the value of age here. Whenever you get a true or false sign, we call that particular stuff a boolean or a bool, and we will continually use them. Now to finally prove that particular fact, let us check the type of answer. So we'll type this type and we'll say answer, and if we run this right now, we should see bool, which shows that type of answer is actually bool. So that concludes the 4 basic types of data that you will actually be working with, and these are some of the most common ones you will work with daily in your data analysis joining and other stuff. Now the more advanced one are something we always classify into collections, and there are necessarily 4 types of collection in Python. We have the list, we have tuple, we have dictionary, and we have set. I'm going to just explain all of this the same way, and then we'll start working with them immediately to see. Now a list is used to store a collection of stuff, collections of data. So you can either store different types of data inside the list. Just think about your shopping cart. Maybe you are shopping for something in an e-commerce website. Think of something like Jumia or Amazon, and you're shopping for something. So whenever you see an item you want to buy, you will see a button of add to cart. So you add that particular stuff to cart. So you can add a laptop to cart, you can add a kitchen utensil to cart, you can add a car to cart, you can add an apple to cart. So you can add different types of stuff into that particular cart. That cart works now like a list. Okay, so that whenever you are going back to whenever you are finished shopping and added everything to a particular cart, you can now just go ahead and maybe remove some items or buy everything that is in that particular cart. So that is what a list allows you to do. A list allows you to add different types of data types into a collection of something so that you can start working with that collection. And we are going to look at how to do that. The next one is a tuple. A tuple is just like it's a type of list, but what it allows you to do is to make sure that you don't add or you don't have repetition of a particular data in your collection. Okay, for example, in a list here you can add different types of number. For example, you can have two here, and then when you add in the next two and you print them out, you will still see all of these things right there. But in a tuple, to remove any number that are duplicates of the next number. For example, this two here, if you print out anything that is a tuple, it's going to remove one of these two. So it will just be left with one. We are going to see that in practical. The next, which is kind of more advanced, and we will not like use it very often in data analysis, but more in programming, like in software development, is a dictionary. A dictionary is like a step more advanced than tuple and list because it allows you to store several things, including list, tuple, Boolean, and every other stuff. The structure of it starts with like two curly bracelets. That is how you define the structure of a list, how it starts. Okay. Sometimes we use to define something called a JSON, which we are going to learn subsequently in our subsequent tutorial. The last type of collection that we are going to talk about is a set. Okay, and a set is defined just like a dictionary, but it has a different usage than a dictionary, other than a dictionary. So let's quickly start with a list. Okay, now the way we define a list, so I'm going to do this a list. Just in case you didn't watch my previous tutorial on this particular series, whenever you see me define or whenever you see me use an hash sign before writing stuff, I'm simply telling the programming language or the programming platform rather that this particular line that has an hash behind it is a comment. A comment in programming language is used to describe a piece of code. So whenever the platform or whenever Python comes across hash before a particular stuff, it automatically understand that that is a piece of explanation that the author of this particular code has added. So it will just skip it, it will not run that particular stuff. That is why if I add this as a list and run it right now, it will not have any effect. Okay. Now let's define a list. I've used an example of shopping cart. So let's simply say a cart, which is where we add stuff on an e-commerce platform. And so we define it with these two square bracket. That is how you define a list. Now inside of this, I'm going to have different items. Because I love fruits, I'm going to say orange. I add some oranges to the list and I separate one data or one item with a comma. So I will add mangoes. So the next one is going to be mango or some mangoes anyway. So I'm going to add these mangoes and then I'm going to add some apples. Like I mentioned, you can add different types of stuff. So I'm going to add 20. I don't know what 20 is, but it's an integer, so I'm going to add it inside. And then I'm going to buy a car. I'm going to add it into my cart, right? So this is a list right now. Okay. Now if I run this particular stuff, if I run this and I save it. Now if I say type of cart right now, type of cart, and then it should tell us that this is a list. Okay, so we now have a list. Now one of the beautiful things of working with a list is that it allows you to perform different operation in your entire list. For example, you can add items to this card without having to redeclare this card again or without having to like create this card from beginning. Okay, so what a list does for us is like it gives us something called a set of methods that allows us to like run some kind of operation. For example, I can come down here and say cat dot append, let's say a pencil. So if I do this, I'm simply saying that inside cat, which is a list, append, in other words, add to the end of that particular list, because that is what append does for you. It adds an item to the end of that particular list. Okay, so I can now say cat.append pencil. So if I run this right now and then I print out cat again. So if I print out cat, you should see pencil have now been added to the end of that list. Okay. Now I can also say I can also use another method called insert, which allows me to add an item to a specific position inside that list. But before we go to that part, let me explain something to you. In programming, we do our counting a bit differently from the way we do normal arithmetic counting. For example, we start counting things from zero. So currently there are about 5 items here. We have 1, 2, 3, 4, 5, 6. Okay, we have 6 items. But in positioning, orange here is in position 0 instead of position 1. We say it's in position 0. While mangoes is in position 2. Apples is in, no, mangoes is in position 1. Apples is in position 2. 20 is position 3. And car is position 4. And then pencil right here is in position 5. Okay, so always remember that it's something you just put into your subconscious. Always remember that we start position counting from 0 instead of from 1. So even though we have 6 items right here, right, so we start counting from position 0. Now the next thing I want to show you is how to insert um something into a specific position. So let's say we want to add another item into our list right now. So we can say cat dot insert. Okay, now instead of just adding it to the end using a pen, now I'm going to say in position 2 add something called a train. So I'm going to add a train to my shopping list. I really need to buy a train. Okay, now what it will do is that it will search through this list and say which is position 2. Orange was 0, mangoes was 1, so apple was 2. It's going to displace apple to the right and then insert train into that particular place. So if I save this right now, and I run this and I print out cards again, okay, I will see that there is train right here. Orange has been shifted, apples have been shifted rather to the right, and then our train appear in position 2 in that particular place. So there are other methods that comes with insert. For example, you can remove something from this particular point. For example, I can say cat dot pop, and I will say cat dot pop. Yeah, so if I just say cat dot pop, it's going to remove and return that particular item to us. So we now have pencil has been removed from that particular place. So if we call our cat list right now, we see that pencil has been removed from that particular list. Now there's another way you can remove a specific item instead of just using pop. That will be the first assignment I'm giving to you. Try and find out how to remove an item from a specific item anywhere in our list. Okay, so what our list allows us to do right now is that it allows us to, like, define a collection of items. So we can just define a list right here and then use that particular list across our entire programming job and everything we want to do. In fact, you can declare an empty list and then you start adding new item to it. So I can just say new cart. Let me say new cart equals to this. So the system automatically understand that this is a list even though it's an empty list. So if I run lens right now, lens new cart. Now lens method is used to find the number of items, or just like the short form of length, it's used to find the number of items that a particular list or tuple contains. So if I say learn new cart right now, it's going to tell me that that cart has 0 item, okay, because there are 0 items inside this cart. But if I say lens cart, which is the cart we've defined previously, and I run this, it's going to say 6 because there are currently 6 items in that particular cart. So with our new cart right now, we can start adding items to it. So you can see that we declare it here, but anywhere in our program, let me just create new cells here. So I can go very far away from our program right here. I can go very far away here, and I can say new cart dot append a motorcycle. So a motorcycle, yeah. So I've added motorcycle now to my new cart. So if I run this, it is going to insert a motorcycle into a new cart. Okay, so if I run new cart right now, new cart right here, you can see that we have an item motorcycle, and now the length of that particular stuff or that particular new cart is now 1. Okay, now that is all we need to know about a list. There are different types of methods that are available, and as you continue to use it in your daily activity or in your daily programming, you will come across them. And the one thing I want to talk before we end this particular tutorial is a tuple. Like I mentioned previously, a tuple allows you to like declare a list without repetition. So let me quickly just give an example. So I'll come here and I'll copy this particular list that we have here. Okay, and I'll come down here and I will insert this to, let me just give it a name. So I'll call new list, or another cat, another cat, and I will send it to this. What I'm going to change is the structure of the parentheses. So I'm going to use the main bracket instead of square bracket right now. I'm going to use the round bracket right now. Okay, that is how you define a tuple. So inside this list now, I'm going to repeat a particular item. So I have a car right here. So I'm going to repeat a car again. So I'm going to repeat a car, and I'm going to add car right here. Okay, so now we have car here, we have car here, and let's just run this and see what we are going to have right now. So we've run that, and then let's print out another cat. Okay, if I print this out right now, we still have our car right here. Okay, so but what this particular guy allows you to do is that it allows you to find out that our car is 2 right in this particular place. So I think I mentioned that with the tuple that I mentioned that with a tuple you cannot have duplicates of values. That was a mistake on my part. The main difference between a tuple and a list is that a tuple whenever you create a tuple, the values of that particular tuple is unchanged. So unlike a list, there are a lot of things you cannot do with a tuple. For example, you cannot add new items to this particular tuple. You cannot also remove new items. The only way you can do that is if you convert a tuple into a string and then add the items and then um return them back. So the main difference between a tuple and a list is something called mutable and immutable. So in programming language, when we talk about mutable data type, so let me just give this simple explanation. So mutable, when we say a data type is mutable, we are simply saying that that data types can be changed. For example, a list right now, we can add items to a list, we can remove items on that particular list. You can also declare variables. Let's say a variable is so name. You can say name equals to somewhere, and this will be stored in that particular place. But you can now declare name equals to Bethel. So when you declare name equals to Bethel, so that same name, the value of that name again is now Bethel. This is because a string, which is the data type that we are using to store name, is mutable. So we can actually change the value that's being stored in that particular place. Okay. A list is also mutable because you can remove items, you can add items to that particular list. But a tuple is not mutable. What that means is that once you create a tuple, it remains that way. The value of that particular tuple cannot be changed. The only way you can do that is if you convert a particular type to, if you convert that particular type, like that tuple, to a list, and then add the items you want to add and then return them back. But I don't think that is quite useful for us right now, since we have completely focusing on data analysis. Okay, for now, this is what we are going to cover in this particular tutorial. As an assignment, try to create a list and remove a specific item from that list and see if you are able to do that. If you can't do that, you're free to like check the answers online. That will allow you to marshal in what we've just covered right now and give you a very solid foundation towards what we are going to learn in the future. Thank you for watching this tutorial. If you like it, encourage me, click the like button. See you in the next one.